Hello guys, I hope everyone is doing well. So in this lesson guys, I'll be approaching this kind of a question there, and don't feel perplexed guys when you see this kind of a question. This question guys are just straightforward there. So if guys you see such a thing there, just relax, and think. Don't think that deep there. Just relax and think there. So here what you can do guys, you can simplify this thing there. Because let's say guys, here I'm not focusing all of this stuff there. This thing, let's say this thing, it's something like this there. If I want to simplify this, those one are just my vertical components there. I'll just say vertical components. And guys, when I got vertical components, it simply says that I will say the resultant force of the vertical components, which is those two things there. Both of them guys, if you can notice, they point upwards there, meaning that it's positive 3. Even that one there, it's pointing upwards, it's positive 3 there. Then you press this thing down your calculator, which is all of this thing, supposed to give you what will just give you positive 5 there, which is in Newton. That thing there is the same as 5 Newton, which is pointing where? Upwards there. That's a resultant force of a vertical component there. Then what about guys, the one which is what? Horizontal there, components. Then for the horizontal components guys, what you should understand, we only got one component there. If I can just hide that part there, you will notice that we only got that vertical component, meaning here our resultant force of the vertical component of the horizontal component there, it's 8 Newton there, to the right there, right? Do you see? So now what I can do guys, I can redraw that diagram again. Now those two things I simplify, they become that 5 there, 5 Newton, and here we got that 8. Do you see? And now at this case, now what I should do, I will take this thing, I will come and write it here, so that here I will have what? I will have Taylor to head. So, and here I will join that to form my what? My resultant force then, to form my resultant force. And at the same time here I got unknown angle there, which is theta there. Then now I can apply what? Pythagoras equation, just like this there. X plus ry in squared there, in squared. Then I substitute here. Then I substitute. And when I substitute guys, I can include those direction there. So here it's 5 Newton. That thing there, it's my what? It is that one there, which is ry. This one there, it is what? Rx there. Then I substitute here, it's positive. Here it's what? It's positive squared. So now when I press my calculator, I can just press all of that thing guys, which is this thing is that the plus 5. So this is what I get, as you can see. So meaning that it's what? It's 89. And now what I can do to remove that 2, you take the what? The square root. Symbol says okay, now what you should get there as a resultant force, the square root of 89. This is what you get there, which is there, it's 9,43 Newton. That's your magnitude, by the way. That's a magnitude. Now what I should get now, it's a direction. Just say it's tan theta. Then I apply that equation. Don't forget that equation here, which is y over what? Rx there. That thing, it's your opposite over what? Over adjacent there. Yeah. And now I can substitute there. Where there is this thing there, I can substitute what? Positive 5. And where there is this one, I can substitute 80 there. Then I will drop this. Then I say tan arc 5 over that. And then I press that thing down my calculator. This is what my calculator is supposed to give me there, 5 over 8. So it means that I get 30. When I round it off guys, this thing, it will become 0 and 1 degree. No need for you to add there. The reason why, it's because that thing there, it is on which quadr? It is on the first quadr. On the first quadr, if you get that theta there, it's supposed to be positive, as you can see. Do you see? It is on this quad that there. And now that you can just conclude there. Yeah, thank you for your time.